Bonjour, Kinamagi and Nene Ireland and Dishnikas, and welcome to this presentation of My Math Television Networks. Today's topic, hands-on distributive property and partial quotients. Potential question, what strategies can be used to divide whole numbers? Yesterday, we were using base and blocks in order to visualize what we were doing. Well, today we're going to move that into the distributive property and drawings. If you notice, we have a natural progression from tactile, things you could touch if we were able to drawing, to without the drawings, and then on from there. The packet today is labeled Lesson 7, Hands-on Distributive Property and Partial Quotient. So you should have that out at this point. If you don't, pause the video and go get it. Assuming you are ready to go, this does start on page 195. And as always, whenever we're going through one of these videos, if at any point we're moving too fast or you need to pause the video to finish writing something in, feel free to do such. The cool part about asynchronous learning is you have a little more control. You don't have to say, Mr. I, slow down. All you have to do is hit pause and then hit play again when you're ready. All right, and we've talked about the distributive property. We did this in multiplication when we were going from area models on in. So this is a term that should not be foreign to you. So we're going to begin with the draw it. Jesse has 369 beads to be split evenly among 3 necklaces. How many beads can Jesse put in each necklace? If you see here, we have the opposite of what we had before, where we had a 3 and then we had a number and then another number and another number, and we multiplied them to get this. We have the number right there. So I'm going to use my annotation tool to point out that this modeling is 300 plus 60 plus 9. So go ahead and make sure that's written in. And then I'm going to clear that because I actually have to move to another slide. You will stay in the same spot. See the answer there. Step 2, divide each section by 3. Let's move me up here. Again, grab my annotation tool. How many times does 3 go into 300? 3 divided by 3 is 1, and there are 2 zeros left over. So I have 100. 3 goes into 6 twice, and there's 1 0 left over, so 20. 3 goes into 9 3 times. So 300 divided by 3 again. We're just rewriting these numbers here. 60 divided by 3 is 20. And 9 divided by 3 is 3. So these are partial quotients. This does lead naturally into another way of solving division problems outside of the old-fashioned standard algorithm, as some students will break it down by going through the hundreds, through the tens, and through the ones with very good speed. All right, so make sure you've written that in. Let's see that we've already done this step here. Now we need to add them up. So I'm going to go ahead and use this way. So we had 100 plus 20 plus 3 is 123. Notice we take the number on the left in each of these place values because those are your non-zero digits. We add them together, it's 123. So 369 divided by 3 is 123. Jesse can put 123 beads on each necklace. I could check my work by multiplying 123 times 3, and I'd get 369. And since those all equal out, we know we are good to go. All right, let's go to the top of page 196. Make sure you have those already filled in. If you need to pause the video to do such, you should feel free. But otherwise, we're going to keep moving forward here. We have a try it problem. In your textbook, you might notice there is a yellow highlighted word, or in your packet. It says partial quotients is a method of dividing where you break the dividend into addends that are easier to divide. It's the same thing as doing partial products, except that we're going the opposite way down the area model. All right, so that does lead in naturally into this style of solving division problems. And I know that in our teaching team, we would immediately look at this style and picture a couple students who did it with extreme efficiency, whereas the standard algorithm didn't work for them. It's important to be exposed to multiple ways, but in reality, when you get out into the real world, you're going to pick one of these ways that works best for you. So it says try it. There are 738 students in Manuel School. There are 6 grade levels in his school, with each grade having the same number of students. How many students are in the 5th grade? No, the answer is not 13. Talking about Manuel School. So step 1 in this one is to divide the hundreds. 600 is close to 738 and is compatible with 6. So we divided by 600 by 6. And that partial quotient would be 100. Also, put it over here. The 6 times 100 is 600. If you wonder what we're going to do with these, eventually each of these partial pieces, we will add up. And you'll notice that we're dealing with the hundreds. And then when we regroup, we'll be dealing with the tens and then the ones. So we subtract just like you would normally, and you have 138. At this point, we're no longer dealing with 738. So if you've had this written down, we'll move on into the next part. So now that we've divided the 100, you see we wrote the 100 in there. There's your answer. Our next step is to divide the tens. So I'm going to grab my annotation tool again, if it lets me. There's the text. We had the 100 already here. So now we have 138. 6 goes into 12 twice, and then we have another 0, so 20 times. So 20 is a partial quotient. And 20 times 6 was 120, and we'll be able to subtract to get to 18. So you should write in that 20 there. Make sure that's written down. Just as a review, 100 times 6 is 600. 20 times 6 is 120. We're just kind of using our knowledge of compatible numbers to work our way down. We clear the drawings. Move on to the next slide here. Grab my annotation tool again. So over here again, we had 100. We had 20. And now we have 18. How many times does 6 go into 18? 3 times. 3 is that partial quotient. It should be starting to look a little familiar here. All right, make sure you've written this in. See our answer key. Now we have to, step 4, add those parts together. So I'm going to go ahead and cheat and use the answer key here. We had 100 plus 20 plus 3, which is 123. There are 123 students in the 5th grade. I could check that answer by multiplying by 6. And if it comes out to 738 for its product, then we know we did well. I know this is different than the standard algorithm that you may be used to, but it is a very functional way to work, and it's a good mental method for doing long division. All right, let's move on to the next slide. How would you use the distributive property to go to 242 divided by 2? So stop and think about that for a moment, and we'll And I'll show you what the book says. I would divide 200 by 2, then 40 by 2, and then 2 by 2, which would give us 100 plus 20 plus 1, which equals 121. And this is probably how you would solve this in your brain. Even though it looks weird to you on paper, you've probably done this more times than you can count. So now we're going to get to where you have a chance to practice. I want you to do numbers 2, 3, 4, and 5 on your own. Use the distributive property to draw the bar diagrams. So you should have 3 boxes on this one with a 900, one with a 60, one with a 3, so that you can see how they work. Yes, it is expected for you to follow the directions to draw the bar diagrams. I'll look for you on the other side. You may pause the video now. Welcome back. Let's see how you did. And I have them drawn out here for you. Well, the book does. 124. So you had 200 divided by 2, 40 divided by 2, and 8 divided by 2. 2 went into 200 100 times. 2 went into 40 20 times. 2 went into 8 4 times. You add those numbers together. Over here, 3 went into 900 300 times. 3 went into 60 20 times. 3 went into 3 once. Add together 321. 5 went into 500 100 times. 5 went into 80 16 times. 5 went into 5 once. 100 plus 16 plus 1, 117. There you go. And finally, 4 into 400 100 times. 4 into 80 20 times. 4 into 8 twice. And together 122. How'd you do? Hopefully I did well. Let's give you just a couple more practice ones. How about numbers 6, 7, and 8 using the partial quotients? You may choose to draw them out using a bar diagram, or you may choose to use parentheses, or you may use the model that was provided with the 6 divided by 738. All of those are partial quotients, but I think it would be a good idea for you to practice using the way you did on 196. So you may pause the video. We'll see you on the other side. Welcome back. See how you did? 3 went into 600, 200 times. That left you with 54. 3 goes into 30, 10 times. That left me 24. 3 went into 24, 8 times. Add them together, 218. 5 goes into 675 times, or 5 times into 500, 100 times. 30 times 5 is 150. 5 times 5 is 25. Nothing left over. You see the hundreds place. 3 goes into 3 once. 2 zeros, 100. 10 times 3 is 30. 7 times 3 is 21. So 117. All right, at this point, I would like you to begin the homework. If you're stuck, you should reach out to me at mireland@sagchipschool.net. Attend office hours at 2 p.m. Or you may even consider using Khan Academy. It's a great resource. You could go in there and type into Google Khan Academy partial quotients, and you'll be able to select videos on the fly. So if you're doing your homework at 9:50 p.m. and I'm already in bed, you can still get information. I hope you all have a minute. Gives you good. I'm a P.